Good morning, everyone. Welcome back to class. Before we get started on the new material, I'd like to go ahead and review some of the material we had from our previous class. Now, if you remember, last time we talked about where the Earth is coming from and what makes the Earth work in terms of its inner workings inside. We talked about what the Earth is made of, namely that it has a core, has a solid inner core, and then a liquid outer core. It also has a mantle, which is going to be also liquid, but it's going to be a little cooler than the inner core. And then we have the lithosphere, which is going to be the upper mantle and then the crust. Now, technically, the mantle is considered to be the upper mantle, the ionosphere, and then what we refer to as the mantle itself. But these are distinctive because usually the mantle is liquid or really thick. The ionosphere is going to be slightly thicker because it's going to be cooler. And then, of course, above that is going to be solid because the further away we get from the center, the cooler that's going to get. And as the cooler it gets, the more solid it gets because the molecules are closer together. Recall that we also talked about the lithosphere being able to move through plate tectonics, and that's a result of a couple of different things. We talked about how the temperature of the Earth's outer core is thought to be the result of radioactive decay of various isotopes or elements, and it's the heat of these elements breaking down that is used to keep the mantle basically liquid. So the heat from the decay causes plumes of hot magma to basically well upward from the core, upward toward the lithosphere, and this produces hot spots on the lithosphere where the magma is able to well up and basically find an opening into the lithosphere and allow that magma to get to the surface. We also discussed the idea of plate tectonics and the fact that the lithosphere is divided up into plates and that these plates are sitting on the magma of the mantle, and as the magma of the mantle flows, it causes these plates to move in different directions. Furthermore, we know that new material as rock is added to the lithosphere where the plates spread apart, and older lithosphere gets recycled or pushed back down into the mantle at subduction zones. So to review the upper part of that last slide, here we have the mantle being liquid, and it's able to move because of convection. So we know that hot material rises and cold material falls. Now, it's not exactly cold, but it's cooler than it was before the further it gets away from the core. So the hot material rises, and as it flows, the force of the flow pushes against the plate tectonics, and when it comes apart, when it's rising up, this is going to cause the plates to spread. And as it spreads, it's going to allow some of the magma to come out, and this is where you have new rock formed. Now, as it cools, the magma will fall back toward the core in order to get reheated, and that will allow the circulation of the magma. Now recall that we have different cycles of this happening on different parts of the Earth. So we have one cycle happening here, it's going to push the plates this way. We can imagine another one being over here somewhere like in this area, and that would force the plate going this direction. When we have two plates moving in opposite directions, we get basically what is subduction or convergent plates. And that's shown in more detail here. So when the plates are moving away from each other or diverging, this is allowing rock to come out because the magma is welling up and making new rock. When plates are moving closer to each other or converging, one plate will be forced under another, and this is where we get the rock being recycled back into the Earth because all this material is being forced downward. And then we do have transform boundaries where they're simply moving against each other and not necessarily pushing away or toward. And this slide just gives us an overall idea of how the plates are moving relative to one another. So we see that some plates are moving away from each other in different directions to form our spreading zones where new rock is being made, or we have regions where plates are moving toward each other where rock is being recycled back down into the Earth. And altogether, with new rock being made and rock being forced back down into the Earth, we have what we consider the rock cycle. And the rock cycle can give rise to different types of rock depending on how the rock is being made, whether it's simply being injected from the interior, this is known as igneous rock, or whether it's being pressed down with other rocks to form metamorphic rock, or after the rock comes out and then piles on top of one another and gets forced down into layers which we call sedimentary rock. Now for the rest of today's notes, we're going to be focusing on what's happening to the rock that has now made it to the lithosphere on the top of the crust, what is going to happen to that rock afterwards? Well, that rock is going to be subjected to all kinds of different forces, and the result of these forces is going to be called. Now, this is basically what's happening is the rock is being broken down into its parts. Now, what do we mean by parts? Well, we're talking about what makes up rock, like the minerals and the elements that go into it. So we're talking about the physical breaking down of rock into smaller pieces. Now, what we're seeing here in this picture is we're looking at how different types of physical weathering can work. Now, I want to keep in mind that we're talking about physical weathering, so we're talking about the breakdown of rock right now that doesn't involve any sort of change in what it's made of. It's like taking a piece of paper and ripping it in half. You've changed with the nature of the paper, but you haven't changed what it's made of. That's simply a physical change. Well, the same thing is happening to the rock. The rock is being forced to break into different pieces. Now, we're not changing what the rock is made of, but it is changing a form. So we'll look at a couple of different ways that rock can be weathered. First of all, water can work its way into cracks in a rock, and what this can do is the water can dissolve some of the minerals and cause gaps, and this can break the rock apart. Also, when water freezes, we know that when water freezes, it expands. Think of, if you put a pop in the freezer, and if you leave it in there too long, it's going to get hard. The ice will basically expand, and it'll burst the sides of the can. Well, imagine the same thing happening to rock that gets down into some of these cracks. As it expands, it helps to push the rock apart, and then create more cracks, and then accumulate more water, and then basically more weathering. Something else that can also happen is the seeds from different plants can fall into the cracks, and as they germinate, when it gets wet, and then you get little sprouts, and then the sun comes out and starts to make them grow. As they grow, they'll start taking some of the minerals from the rock. What's more, as they develop, the plant itself will start to break down the rock in order to take those minerals more, and as it grows, the roots will force its way into the rock, and then even force it apart even more. Now, physical weathering is not the only kind of weathering that can happen. In addition to this, we can also have chemical weathering. Now, as you might imagine, this is a change in what the rock is actually made of. So this is weathering that involves a chemical reaction, so perhaps dissolving of chemical elements from the rocks, or the rocks being broken down by chemical means. In any case, what we're doing is we're actually changing what the rock is made of in this process. So in that sense, it's also being broken down. Now, one of the things that we've heard about in the past that relates to chemical weathering is acid rain. Now, what happens with acid rain is chemicals from pollution mixed with the water, the vapor in the air, and then as it condenses and then comes back down, those chemicals are still in the water. And then when it comes down, the acid rain reacts with the rock and then starts to break down. Remember, some of you remember that one of the characteristics of an acid is that it is corrosive. That means it can break other stuff down. So acid rain is able to do that with rock. Now, another process that contributes to breaking down rocks is related to weathering. It's part of it, but it's not exactly weathering itself. Here we're referring to erosion. Now, what happens with erosion is the rock is still going to break down, but instead of staying put, some sort of physical removal happens to the rock fragments that are made. So when weathering breaks the rock down into different parts, it's erosion that will cause the removal of this rock to different areas. So we usually think of erosion as like seeing something big like a rock or like a valley or some other plain, where basically the material is gradually lost over time. And that's usually a result of like a wind, water, or ice, making materials move. Another thing that we can see happening is living organisms, as they burrow down into the soil, they're going to kick soil out of the way. They're going to physically move the soil from one place to another. So the erosion is simply the movement of the material that happens after weathering occurs to it. Now, the reason that this is important is that this is where soil comes from. So soil is basically broken down rock with other things mixed in with it. Now, what we see in this slide is a cartoon showing how soil can form over time. So in the first part of this diagram, we see how weathering is beginning to break the rock down, and then this serves as a substrate or a medium for other material like plants and fungus or stuff like that, will start growing on it, and as they grow, this will in turn help more weathering and break down more rock. Now over time, this soil starts to develop because we start to see more and more material starting to grow on it. Now as it grows, it's eventually going to die, and as it dies, it goes down into the soil, and this becomes food for other microorganisms and stuff that are living in it, and that will enrich the soil because that will also help break down the rocks into more soil. So now we're beginning to accelerate a bit because we have more organisms that are taking advantage of all this breakdown. Now, I did want to make sure everyone understands what we mean by organic material. Now, usually when we say organic, we're talking about material that comes from something that used to be alive. Organic comes from the fact that it's referring to organs in the body. And since it comes from living things, organic material is anything that derives from living material. So organic material can be dead, but the point is that it came from something that used to be alive. Now, as the soil matures, we get the generation of more and more organic material, and now things are growing in it. We see even more weathering because we see the roots moving down in there, even more water freezing and then breaking out the rock, making it more accessible to the microorganisms that are living in the soil, and then further even breaking down even more rock. So now we have an even richer soil. So I would like you to keep in mind that soil is going to be a mixture of inorganic material. This is stuff that's derived from the rock, for example, minerals. Inorganic material is something that was never alive to begin with. Now, since rock was never alive, that's why we consider it inorganic material. And then the soil, of course, is a mixture with organic material. This is material that was growing on it and has died and is enriching soil. And that brings us to our first seed question. So our question today is, what would you expect to see as rocks are broken down into soil and this allows living things to grow in it? So the teacher is going to pause the video, give you a minute or two to talk about this, and then we'll start it back up again. All right, teacher, pause the video now. Okay, we're back. So, after all this breakdown, what would you expect to see as the rocks are broken down and this allows living things to grow in it? Well, if we go back to the slide that we're referencing, you'll notice that as time goes by, what do we see developing as the soil is becoming enriched, as we start to form more of this more and more mature soil? Well, what begins to happen is we see the formation of different layers of soil. Now, I hope you recall from that soil scientist from the Bill Nye video you watched that the soil can be thought of as existing in different layers. So we're going to be referencing these layers according to the very top of the soil. This is basically the zero height would be the very top of the soil, the part that we're actually interacting with, where the living stuff is. So this top part, this top layer, which is basically the down to about maybe 1/10 of a meter, this is called the O horizon. O is for organic. So this is the organic layer. This is where most of the living stuff is happening. It's composed of organic waste, so this may be like from dead organisms or from animals in various stages of decomposition. Now this decomposition is important because as it decomposes, it's breaking down not only the organic matter, but also anything else that's there to break it down into its parts, and this is what the plants and other organisms are living on. Now the O horizon is going to be the richest in organic matter because this is where most of the organisms are going to be, is on the surface. And as they die, they'll contribute their material onto that layer. Now below the O horizon is what we call the A horizon. And this is frequently what's referred to as topsoil. So this is organic material from the dead things, and also minerals that have been mixed in together. So this layer contains most of the soil organisms. That's because as it's moving down, as you have more material, it's being forced down, and then this material, the broken down material, can then filter down into the soil. And that brings us to the E horizon. The E stands for eluviated, and that's just a fancy word for saying that material gets washed down by water as it flows from top to bottom. So as all the organic matter on the top dies and begins to decompose, when it rains, the water will then filter down into all the pores in the rock, and as it flows down, it's going to carry all that rich material, all the organic matter and dissolved material, down further into the soil. As we move further down into the soil, then we get to the B horizon, And this is soil that's composed primarily of mineral material, such as clay. Now notice that it says very little organic matter. That's because all the dead stuff hasn't had a chance to get down here yet. The water, as it flows down, is only going to take these minerals so far. So as a result, we have some rock that hasn't been broken down very much. Now we go even further, then we get to the sea horizon, and this is considered the least weathered soil because this is basically the parent rock. So that means this material probably used to be part of this rock, but it got weathered and then broken down by either rain, wind, and other living organisms. So this is material that has not been broken down yet. So what's called parent material or original rock. Now that we've talked about where soil comes from and some of the layers it can form, so I'd like to go into some of the properties of soil. So what are some of the properties that we get as a result of this rock being broken down into this other material? Well, there are three main properties of soil. They are physical, chemical, and biological. All right, so for physical properties, remember we said before that a physical property is something that does not involve a change in what it's made of. So it's going to be a change, but it doesn't change what the material is made of. So in this case, some of the physical properties of soil would be the size and weight of the particles, so how big they are, how much they weigh. You can change the size of it or how much you have, but you won't change what it's made of. Also, the texture or how it feels or breaks apart, determined by the percentage of the different parts that make up the soil. And then there's soil permeability to water. That means the ability of water to pass through it. Permeable means to be able to go through it. And this is somewhat dependent on the texture. Now for chemical properties, we're basically talking about how soil participates in chemical reactions. So now we're talking about how the soil is actually going to change what it's made of, and also how the soil can change how other things are made. So some of the properties involve what's called cation exchange capacity. Now this is just a fancy way for saying cation. Remember, that's a positive charge. Or exchange means you're changing one for another, and capacity means the ability to do it. So we're talking about the ability of a soil to absorb, to take in, or to release positive charges. This is dependent on the type of material that makes up the rock. Another chemical property is what's called base saturation, and this is simply a ratio of how much base there is to the acid in the soil, and this is usually expressed as a percentage. Now this is important because this relates to how well the soil can resist any sort of insult like acidic rain or any other insult like that. And then our third main property is biological, and this refers to the activities of all kinds of different things that are living in the soil. So for example, we have like fungi, like mushrooms, bacteria, protozoans, single-celled organisms. Now these three usually make up to 90% of the organisms that are there. But in addition to that, we have all the things that you would associate with soil, the things that we've seen before, such as snails or slugs, snail without their shell, insects, various other organisms. Now these are important because they help to determine the different kinds of things the several functions that soil can actually perform. So it's important to remember that soil links the rock cycle, the making of rocks, and the biosphere with the living world. So the soil is sort of the bridge between the making of the rock and everything else that depends on it. So some of the things that soil can do is it can break down organic material and recycle the nutrients. So as the living stuff dies and then goes down to the ground, the soil can help to rebuild that, to renew things. Also, it's a media for plant growth. Remember, we usually think that plants grow in soil, so that's needed. Soil can be used to filter water, and of course, it's a habitat for a variety of organisms. So, what are some of the characteristics that determine the properties of the soil? Remember the three properties, physical, chemical, and biological. So, what are the characteristics that help determine these properties? Well, there's the parent material. That means what was the soil made of, the type of rock. And remember, there are three types of rocks: the igneous, metamorphic, and sedimentary. There's also climate factors, such as temperature and precipitation. Topographical features, like mountains, valleys, rivers, and so forth. Now, those should sound familiar. We'll get to that in a moment. And we have the different types of organisms that are living in the soil. And finally, the last characteristic that helps determine the property of soil is time. How much time is given for these processes to happen. Now, for these characteristics, I would like you to take a moment and think of this question. How would some of these characteristics, the one we just reviewed, how would they determine the properties of the soil? All right, teacher, pause the video at this time, please. Okay, so now the question is, how would some of these characteristics, the 5 characteristics that we just learned about in the previous slide, how would they determine the properties of the soil? Well, one of the things that happen is the parent material, the type of rock that goes into making the soil, that can influence its texture, how it feels, and the ability to let water pass through it. Also, climate factors in different biomes. Remember that we talked about mainly temperature and precipitation. These can influence how fast rock is broken down into the soil, particularly how much water is formed and the temperature is needed for it. Different topographic features can affect moisture levels and the presence of organisms. And again, this sort of ties in with the climate factors with different biomes. And different organisms can affect the amount of organic matter that is present. And since organic matter helps to influence the growth of other organisms, this is important to consider. Okay, now we're going to go a little more in depth into some of the physical properties of soil, because these are the properties that you're most likely to encounter with soil. These are the ones that we can actually measure physically. So we know that the physical properties of the soil are relating to its texture, its porosity. So soils basically consist of a mixture of 3 different parts: clay, silt, and sand. The clay would be inorganic material, so this would be related to some of the original parent rock. Silt is a mixture of inorganic and organic material, and then sand is also part of the inorganic material. Now, the relative proportions of these particles, that means the relative amounts, the amount of these relative to one another, this will determine the texture of the soil. Now, the figure you see to the left of our text here, this is called a soil triangle. That basically refers to the texture of soil related to the different percentages of the material that go into it. So we have different percentages of sand, clay, and silt. Now, different soils can have different amounts of each of these 3 components, and soils can have different properties based on these percentages. Now, we just mentioned that soil is a mixture of clay, silt, and sand. Now, let's take just another look at these 3 different parts. Now, down below the soil triangle, we have a comparison of the sizes of the different particles. Now, we notice that clay, each of those particles are the smallest of the 3. So it's at less than 2/1000th of a millimeter, which is pretty darn small. So we're talking about really small particles. Now, bigger than that, we have silt particles. Now, as you can see, they're quite a bit bigger than clay. And then still bigger than that, or at least potentially bigger than that, are the sand particles. Now, what we're looking at, we're seeing a sort of a range of sizes. So the sand could be as small as 5/100ths of a millimeter, or it could be as big as 2 millimeters. It just depends on how the sand was formed. Now, as you might imagine, having different percentages of each of these parts can have drastic effects on the texture or the consistency of the soil. So to consider that, we look at what's called soil texture and consistency. And an easy way to do this is to simply gather an amount of soil and perform what's called a ribbon test. So what you do is you take a small amount of soil, you moisten it, then form it into a ball, and then you squeeze and pinch the soil. Now, whether the soil forms a ball or a ribbon determines what type of soil it is. That means whether the greatest proportion is going to be sand, silt, or clay. And the consistency of the soil is basically how well the soil resists the pressure that you're applying to it. So the soil can be sort of loose, meaning it falls apart easily. This would be something you would see if there's a lot of sand in it. Then we have like soft or hard, whether it's soft to the touch or whether it doesn't break apart easily. It doesn't actually resist pressure. Then we have something which is called friable. Think about toast that's been baked too long. You know how it tends to flake apart? Well, that's what friable means. It means it breaks apart very easily once a small amount of pressure is applied to it. And then there's firm. So this is almost the opposite of friable. It means you would need to add a lot of pressure in order to break it apart. And then we have like sticky or non-sticky, or plastic or non-plastic. Now, plastic is simply a word that means capable of being molded or permanently deformed. So that means if you put some pressure on it, it changes its shape, and it's going to stay into that shape. So what we see is, at the top of this consistency, the looser it is, usually the more sand is going to be present there, and the more plastic it is, the more clay is going to be present in the soil. Now, while the soil is in the ground, it's also going to be subject to different kinds of pressures and forces that are going to help shape the soil into different consistencies and patterns. So there are three main types of soil structure that we consider. First of all, the first type is called the granular structure, and it says here that it resembles cookie crumbs, and it's usually less than 0.5 centimeters in diameter. So this would be about 5 millimeters. This is commonly found in surface horizons, so this would be like in the O or the A horizons, where a lot of roots have been growing. There's also the blocky soil structure. Basically, this arises from having irregular blocks. That means blocks of different shapes and sizes that are not necessarily consistent. They sort of kind of glom together. There's the prismatic soil structure. This consists of vertical columns of soil, and they can be a number of centimeters long. It depends on the soil, and these are usually found in lower horizons. So this would be like in your B and their C horizons. All right, then we have the columnar structure, which is vertical columns that have a salt cap at the top. Now, salt cap just means that salt has formed at the top of these. So this would be similar to prismatic. The only difference is that you have some of the material on top of these columns. And usually these are found in the soils of arid climate, because if it's arid, it means it's going to be dry. And if it's dry, the water is going to evaporate, and it's going to leave behind any material that's in the water, particularly it could be such as salt. All right, there's the platy structure. Was just as it's described here, thin, flat plates of soil, and they tend to lie horizontally. Now, this is usually found in compacted soil. That means this is where some sort of pressure from the top is pressing down on the soil and causing it to form layers. And then there's the single grain structure, where the soil can be broken down into individual particles that don't stick together. And this is usually accompanies a loose consistence, so just think of something where there's a lot of sand. There's not a lot that's going to hold it together. Right. To summarize, soil is formed from the weathering of rock and the addition of organic matter by other organisms. The soil can form different layers or horizons depending on how much breakdown of rock has happened. The physical, chemical, and biological properties of soil determine the services or the different things that soil can do or provide to its biome. So soil can be made up of differing ratios of clay, silt, and sand, and it's the different amounts of each of these that will affect how it holds together and what structure it will have. And that concludes today's notes. The teacher now has an assignment for you that will help relate how soil relates to us and what impact it has on us. All right, thanks a lot, guys. You have a good day.